Welcome back to ZINC 2021 conference program that continues at noon sharp with a very interesting topic. So we have a first panel at this conference. The title of this panel is Autonomous Driving, All the Promises and Failures. Very, very challenging topic, but what I believe is that we have both the experience and the integrity to discuss this. I will take up the role as the moderator of this session. So my name is Milan Bjelica, and I have been involved in the automotive related activities for quite some years now, as an affiliate of both RTRK Automotive and TTTech Auto. So basically I will try to, let's say, navigate the discussion a bit, but the roster of speakers discussing with me today is a very good representation of the industry from different standpoints, and I believe they will be able to provide some valuable insights on the topic. So first, a roll call, so to figure out who is actually on the call, because this is a perk of Zoom. So we check the list. We see that the panelists are mostly here. We'll check in again. So I will ask Professor Hans Tschürtz first to introduce himself shortly and to let's say just in one or two sentences state his presence and his role, etc. So nothing too big, and we will take this initial round just to see who is here and to hear the names and the titles of people. So please, Professor.
Yeah, good afternoon. Thank you, Milan, for inviting me to this discussion. I'm very happy to be here.
Thank you.
Is it enough, or shall I say a little bit more?
Maybe it's even good for now, just to see who is here. Let's see, Joerg Zimmer. Probably he's also here. I saw him in the list.
Yes. Then also hello from my side, and I'm also very pleased to be here, and I totally agree. We have an exciting panel for and hopefully exciting discussion today.
Thank you, Joerg. Then Mr. Christoph Herzog.
Hello, Christoph Herzog from Elektrobit. And Milan, thank you very much for the invitation and really the chance to talk here.
It seemed like the audio stopped. Christoph, did you want to say anything else, or that was?
No, nothing else. I also skipped the introduction then. I thought just that I'm here.
I'm trying to practice the new ways of non-verbal communication, looking at the screens.
Good.
In front of me, so pretty much the amphitheater here is almost empty, so just a few seats here in the rectorate building, although we tried to, let's say, create the hybrid event. It actually happens here from it, so I'm barely being able to look here out of these lights. Okay, so thank you, Christoph. Let's see whether Professor Bogdanović has arrived. Maybe not yet. And we have Christian Schlaeffer, so he should be also joining us from a very far away, from the Far East, perhaps. So I don't know if he found his way into the call.
Yes, hi. I found the way from Shanghai,
Okay.
and I'm here. So looking forward to participate.
Okay, great. I'll just ask my colleague Ivan, that is in our editing room, to keep an eye on Professor Bogdanović. So whenever Professor Bogdanović is available, that we will be alerted, so that I can include the professor in the discussion, because I think the insights from Professor will also be really interesting. So let me start by let's say the first general question that I have for my panelists today. So it is, let's say, a warm-up question, like new developments in autonomous driving. So we all know that there are some companies developing some autonomous driving solutions. There are some cars with safety drivers driving around the US. We have this in China as well. We're starting to have this in Europe as well. And we now heard in latest days that the United Kingdom were granting some permits for the self-driving cars for testing, of course, not for the wide utilization. So just maybe to take one round to, let's say, now make an official introduction, so to understand what each of the panelists is doing and what is actually he's at these days. So what kind of developments, what kind of activities are in the companies or in the institutions you are currently at, and let us try to figure out the state of the industry in the autonomous driving development from your very examples, at least what you can share with us. I know that some things are under strict NDAs, but probably there are some, let's say, openly available things that you can share with our audience. So we can now start from Christian, as in this round, because I know that Christian participates in a very exciting venture in Shanghai. This is Technomus. So Christian, please tell us what's new at your end.
All right, so just maybe just a short introduction. So I am the Deputy GM of a joint venture between TTTech Auto and SAIC Motor Group, which is the biggest car manufacturer here in China, with a turnover of about 130 billion euros a year. We established this joint venture in 2018 in order to address the domain controller market. So we are developing domain controller for automated driving. We are doing hardware and software, in specific the software platform, and provide this to OEMs, not only to SAIC, but also to other OEMs. Maybe one thing what I want to mention before we go into deeper discussion about the autonomous driving, because most of the people know that China is the biggest automotive market in the world, but less people know that we have a very, very, I would say, differently structured market here in China. So we have about 100 OEMs here in China. Most of the OEMs are coming up right now in terms of new electrical vehicles. This is something what drives the industry very much here in China, because it's much easier if you start with a new company and with a new development of a car, with electrical vehicle car, instead of changing structures within an organization and changing the system architecture, changing the whole supply chain and so on. So coming maybe to the actual situation, so I just noted some numbers. So by today, by 2020, we had in China around 6% of the produced car have been new electrical vehicle cars. And we expect in 2025 around 25%, 25% electrical cars produced here in China. And 75% out of that will have intelligent driving functions. Right now, based on the actual statistics which we know, or which we have, and which we are using also for our marketing, the penetration rate for level 3 cars are quite low, to be honest. So we're talking about 1%, something around that, maybe less. Level 2 cars, there we already see some movement. So we also expect, let's say, a dramatically increase of level 2 plus and level 3 development projects within this year. So there will be a big step forward. Just to give you some numbers, in 2020, China has invested in automated driving projects around 8 billion euros. And in 2021, we expect an investment volume in AD projects of about 12 billion euros. So we see a huge investment and also a very much fast step forward. The Chinese market, and also supported by the Chinese government, is investing very, very much and supporting the industry very much.
Mm-hmm. I think it was really insightful, especially for us here in this part of the world, that we are mostly unaware of what is actually going out in Asia, in China specifically, yeah, because there's a huge market there, that's for sure. We can now maybe contrast this with the developments in our closer vicinity. I would now give word to Christoph. Maybe he's the closest to some, let's say, actual end products when it comes to this field, to give us a few words on what is actually new in autonomous driving at your end, and also maybe to give us a bit of introduction on your role and your activities.
Good. So my name is Christoph Herzog. I'm responsible at Elektrobit for the portfolio and product management. So responsible for handling all our products and making also successful projects with them. What we see in the new developments, let's say specific in the autonomous driving, also something that Christian mentioned is that the centralization in the car is getting, let's say, more and more important. When we started as Elektrobit our journey, let's say for autonomous driving, it was 2010, where we had started a strategic partnership together with Daimler. And what we did there is that we really took all the software functions from the developers, which were MATLAB Simulink based, and made them ready for serious production. And the interesting movement there is when you started really with level 1 functions, so really just support functions. And these functions were all running on, let's say, on real-time computers. So really small ECUs, every camera module has an own ECU. And what we see now as a really also challenging and a new development in autonomous driving is the movement towards centralized functions. So that Linux and really hypervisors we knowing out of the computer industry are getting more and more involved also in the automotive industry. And the first experience we had was together there with Volkswagen, where we launched last year together the ID3, where we made together also body controller and provided there the complete software. So really from hypervisor Linux to also the AutoSAR solution. And this is really an interesting movement. We see that, let's say, the centralization of functions is getting more and more aggressive in the car. So, and this is just roughly, let's say, our experience. We have just short insights with Daimler and VW, and yeah, I think
what is the level of autonomy, Christoph, that is expected from your solutions
level 2
currently, let's say, and in close future?
Yeah, I think we will also continue with level 2. Some will try to go level 3, but my personal opinion is level 5. We are far away, and also level 4. To really have cars completely autonomously driving, it will take some time. And also let's say the test is going, the investment is going there in this direction, but until really also society is moving in the direction to accept this movement that the car is deciding really everything, I think this will take some more time.
We'll get back to that a little bit later as well. I wanted just to check the standings first and to see. Okay, thank you very much. This was very useful, and you opened up actually the floor for Joerg to comment on. Now Christoph mentioned centralized design, centralized architecture. So yeah, it's taken for granted that this might be some kind of software platform that is based on some kind of magic operating system that can deal with everything around. So let's see whether it's actually feasible. I would not share my views on that now, but I will let Joerg tell us. Of course, he's in the shoes of his company, so probably he's going to be promising in his words. But let's see what's out there with regard to platform software and how well it is being utilized currently in level 2 autonomous vehicles.
Okay, so then let me introduce myself. My name is Joerg Zimmer, and I'm as Vice President at Blackberry QNX, responsible for the sales organization we have in EMEA. And in that role, we are working closely with the OEMs and with the tier 1s and tier 2s to talk with them about the challenges they have to face and to discuss with them where we add value with our products or with our services. And one core product is obviously the operating system. Now, one thing we noticed since a couple of years and especially months is nowadays, everybody's talking about their own operating system. So virtually every OEM is putting that in their mouth and saying, we are developing our own operating system. And we notice they have a bit of different understanding what the operating system means compared to the understanding we have. And we're also pleased to see that we are quite often an integral part of the thing they describe as their operating system. Because what the trend we are seeing already since a longer time is the software competence is key in tackling requirements like, for example, autonomous driving. Obviously, compute power is needed, but software is the key to address the technical challenges. And there, the operating system is an integral part, and also the software layers on top of that, which are also quite often included in by the OEMs in the topic or in the name operating system. And that's where we are quite active with the OEMs to help them gain the software experience, and also to figure out where they want to learn more and to do more in the future on their own, because software competence is key in that market.
Mm-hmm. Yeah, so definitely, you should be on the lookout of who is doing what and trying to help in the best way with the platform solution. I think, Joerg, the inherent need for integration in the phase of software development, let's say, is there in automotive. So when we speak in operating system terms in consumer electronics and in, let's say, computing world in general, we see operating system as something that is, let's say, completely independent outside from the use case, etc. But I think in the automotive arena, you're working closely with both silicon makers, with the OEMs, etc., to make the integrated product. So maybe just a few words on there for us to figure out how decoupled this is currently, or it is still very much coupled in the integration projects.
So, as the automotive market, especially when we're talking about autonomous driving functionality, has to address functional safety requirements and also security requirements, the close coupling with the silicon vendors is quite important. And obviously, we are also helping the industry to create useful abstraction layers, because that's needed for cost reasons, but also for reuse reasons. And that's something we're working, that there's a decoupling to the higher software layers, because the end customer doesn't care too much what's hidden under the surface. And in the end, we are under the surface. And that's where we still have a very tight coupling with the hardware coming from the silicon vendors, also from the different tier 1s, tier 2s, from the technology providers, from LiDAR, radar, camera systems. And that's where we are working, but really below the surface, so that the OEMs and tier 1s can then have on a higher abstraction layer their level of independence and are abstracted from the hardware.
Okay, thanks. So hopefully it's going to work. Let us now span out to a little bit different field. Now, Professor Tschürtz, you heard the current developments. So do you have any immediate customers with regard to, let's say, safety and systems engineering from automotive world? So what is going on these days from this side? Okay, we know that everybody is developing things. Is anyone coming to you asking for how safe they are going to be in the end?
Yeah, mostly the students are asking that question. Yes, this is a big topic, and I think nearly everything was said until now. What's behind that topic and what are the challenges? But let me give you a short view from another side, from the research side on the one hand, and from another branch. First of all, my name is Tschürtz. I'm leading the Vienna Institute for Safety and Systems Engineering in Vienna, and I'm also leading a master study program on that topic. And we have started dealing with the research topic inherent system safety for autonomous systems in the context of systems of systems. That sounds very, very complicated. Honestly speaking, it is very complicated because we are working a little bit beyond the functional safety, because we are in the opinion that functional safety is not enough for autonomous systems. So we need system safety, safety on a higher level on the one hand, and on the other hand, we would like to develop safety into the systems. This is very important. On the one hand, we would like to avoid as much as possible safety functions, because safety functions goes always on costs of availability. So we need also availability, not only safety for that. And if you are talking about autonomous systems, then we are talking not anymore only from systems, we are more or less talking then from system of systems. This is a much broader system context, what we need for that. And then we are not only talking about technical systems, we are talking about entities. So that means this is going to be more and more complicated. But a short view on the field where we are, where we have our research projects. The idea to that to these autonomous systems came from a student of mine. He was working on an initiative. This was called Tram on Demand. So the idea behind this initiative is concerned about putting disused single railway track lines, railway lines back into operation with autonomous vehicles, with so-called people movers. So on the one hand, it is very challenging because we have developed in a 3 years funding project a safe logistical concept for that, so that these people movers can travel on the single routes at the same time that more vehicles can travel on the single lines without the collisions and deadlocks. This was a challenge. The next challenge is now, we are now in a second project with ÖBB. This is the Austrian railway provider. Here we are developing a simulation tool that we can simulate every single railway line in Austria, so that we know how many vehicles we need on each line, how many, how long it takes to come from one place to another place, and all those kind of things. These are big challenges, but now the biggest challenge behind that is, honestly speaking, is obstacle detection on railway crossings, for example, so railway stations, obstacle detection, obstacle interpretation, interpretation of the situations. These are the big challenges at the moment. And what I can see, and this was also mentioned from the other ones, is we have only a few safety standards for that, but no one of these functional safety standards, we will need it also for such technologies, but all of these safety standards are not really fully useful for autonomous systems.
Yeah, we know the genesis of the safety and everything, and it will be a very challenging route. So what do you think, Professor, that from one side you described some research, let's say topics that deal with managing basically the complexity of the autonomous, let's say, vehicle in the end of the day, in some way that we know what we are talking about and how we can correlate things and how we look at the thing at a more let's say, safety relevant or inherent safety view. But if we have a research stream going like this, and we have the industry trying to maybe plateauing a bit and maybe even dropping, so where the two are connected, so do you have any, are the two worlds completely separate, or you see some of the connections already? So what is your experience as for the touching base in your institution?
In my institution, there are a few companies, they are very interesting on that. But honestly speaking, the effort for the safety topic is rather high for autonomous systems on the one hand. And on the other hand, there are a lot of open questions behind that, a lot of open research questions. So what we would need also, as Christian Schlaeffer has mentioned, we need a few billion euros for that. Then we can be connected closer together, let me say.
Yeah, and everyone was kind of rushing through. So it's spending money in this initial phase, and yeah, maybe now it's time to reconcile a bit and to see what is actually the best direction. I think it happens nowadays as well. And you were speaking about obstacles, obstacle detection. I think this gives a nice introduction to Professor Bogdanović from the Faculty of Technical Sciences. He's actually coming from the traffic side. So this is Department of Traffic. And I invited Professor Bogdanović, and I learned from Ivan that he joined us in the meantime to share a few views on actually the regulatory and traffic-oriented aspects. So what is his impression based on his projects that he's dealing in currently? Is there room for autonomous systems when it comes to our roads, when it comes to our signage, when it comes to our road markings, when it comes to the environment, when it comes to people in the end of the day, and legislators? So as being obstacles, being the physical obstacles on the road, but also some invisible, let's say, background obstacles that we can see. So if Professor Bogdanović is here, I would give him the word to introduce himself and maybe share a few thoughts on what I just said.
On the first, I want to thank Professor Bjelica for invitation, and with pleasure I take part in a panel discussion. My research area actually is traffic flow theory and regulation of traffic flow, and I can say that engineers in my fields see problems related to autonomous vehicles. I'm sure that all problems related to participations of the autonomous vehicles in the isolated system that are similar to highways in the acceptable levels of service can be easily or relatively easily solved in the next step of autonomous vehicles development. But many problems expect autonomous vehicles in mixed traffic flow conditions, especially in surface when vehicles share space with other participants who do not have a communications model such as pedestrians, bikes, bicyclists, and others. There are intersections of all types, namely drive moving of these participants depends exclusively of their behavior. In these conditions, pilots don't have a chance to clearly define next step of example pedestrians or bicyclists. Behavior of this type of participants depend on many factors which are not the technical. Especially complex situations are, for example, shared space zone or vulnerable zone. What that autonomous pilot do in this situation? How to recognize any potential risk, for example, some physical disability or mental state, and how artificial intelligence solve these problems? And it is very, very big question. Pedestrian can be anybody. What about disabled people? Only Novi Sad has more than 20,000 disabled people. Actually, all of us in some period have characteristic of disabled people. For example, when we was very, very young, we was disabled people, and when we'll be very old. Also, we will be some type of disabled people. And it is a very, very big challenge, I think, for engineers who develop software for autonomous vehicles. In my opinion, also the second challenge, saturation and oversaturation traffic flows. Namely, for level of service A, B, C, D, there aren't problems for calculating capacity, average speed, delay, and define all other parameters such as critical gap, adjustment factors for left turns, etc., and other. But when is the level of service C, the leap change is occurring. Relation between traffic flows parameters aren't valid in oversaturated traffic flow conditions. Very often, laws and rules aren't valid in oversaturated traffic flow condition. Very often, driver can wait to make communication with others, and by hands, eye communications and other, and make special conditions and special regulation type, which we don't recognize, and we don't have a good methodology for calculating something. In this situation, when traffic flow has oversaturated, characteristic braking, delay, and shock waves is normal occurrence. We cannot solve all of bottleneck on the street network and prevent traffic jams. My question is, what autonomous pilot doing in traffic jam situation? How solve it? I don't see some good way to solve, for example, this type of problem. In traffic, in real traffic flow, there are more challenges for software and the construction of vehicles, and Professor Hans talking about safety problems, and it is very demanding for next steps of autonomous vehicles, I think.
Professor, it ends up like we're expecting that we need to model the physical world consisting of all those unpredictable, or should I say unforeseeable situations. So we should be modeling pedestrians, we should be modeling people, we should be modeling the mental state of drivers. It happened to me a lot of times that the only way to merge on a lane was to signal the driver next to me by waving outside of the window or nodding my head. So these are some of the small examples of how hard it is to model the physical world. And I think the more variables, the more inputs are in this modeling requirement, the harder it is to develop an approximation of the model so that your algorithms can work with them, and then again subsequently drive the autonomous vehicle. And of course, I think the hardest one to model is the urban driving, is the pilot in cities and in urban and heavily populated areas. So I heard predictions a couple of years ago. They were saying 2022, 2023. So we are 2021 now, and it's far, let's say, it's completely missed, I would say, for that level of autonomy, and for some others as well. So why we wait so long for urban autonomous driving, or for this real autonomous cars? And let's go one additional round now. We heard the technological approaches, we heard the states, we heard the problems. Let's say why the technology is still not answering fast enough. As I can put myself now in the shoes of the consumers. So yeah, we are seeing all the commercials even. So the level 2 autopilots are being advertised as autonomous. This word is very dangerous, so to say, because I feel like I shall be sleeping at a steering wheel, whereas in reality, I should not be sleeping because I need to be there to retake the drive. So Christian, what do you think? Why we are still behind?
I would say, from my point of view, from a little bit more practical point of view, I think beside the challenges on the algorithm, we are also facing a huge computation power challenge, I would say. Just for you, for giving you a little bit a feeling what I'm talking about. So I think for all of us, it's clear that the whole industry is now changing from a distributed architecture to a centralized E&E architecture of the vehicle. So, but it also needs some more computation power. So our first platform, which we have developed here with and I can say this because it's already announced, with a Japanese chip provider called Renesas. The calculation power was maybe, I would say, around 0. something tops, so terabyte operations per second. Right now, we are working on a computation platform with about 1,000 tops. Yeah, so it's not only a step 100% more. So we're talking about a step of 1,000, 10,000 times within, I would say, 4 years. Yeah. So the computation power, I think, is something which is limiting us in the development of the functionalities. It's one topic. I also think that the safety is a very crucial key of success. Not only from the legislation, I also very deeply believe that that will be, even if nobody wants to have this, but it will be a differentiation if you have a safe car or not, of course, because you know, to step into a car where you are not sure if you can go from A to B without having an accident, it's unacceptable, I would say. And right now, the safety, not only the functional safety, but also what we have just mentioned before, the safety of the intended function, and also the cybersecurity. All these are challenges which we maybe have a little bit underestimated 3 years ago. So the good message is that the whole industry has moved already, and they see these challenges and they recognize these challenges. And the second good message is, I believe, at least here in China, there's a lot of money available to develop new functions to face this kind of challenges. But the computation power is, from my point of view, a huge topic. And the second topic is, from my point of view, the second issue is the building up the knowledge in managing this kind of complexity. That's, from my point of view, also one of the biggest challenges we are facing in the industry. So finding 1,000 people for software development, that's possible here, even within 1 or 2 years. Yeah. But to bring them up, that they are able to understand safety, that they're able to understand algorithm, that they're able to understand how artificial intelligence can support. And in parallel, we have a huge development on all different layers. I think this is something, managing the skills is something which is limiting the pace of development.
Thanks a lot. This was really insightful for me. Also, so the computation power, this is one thing. The safety in general is we don't know how to model it completely is the second, and the lack of, let's say, know-how in the industry as opposed to the required numbers is the third. I think this was the great opening, but let's tackle these items in a bit more detail. When we speak about performance, I don't have, unfortunately, a member of the silicon company developing chips for automotive, but I do have the closest proximity to it in Joerg. Joerg, you are probably the closest to silicon makers for cars. So what they are up to? Are they able to deliver on the promises? Is really the lack of chips, the high performance microcontrollers, what's disabling the intended functionalities for autonomous vehicles?
So Christian is obviously right that a lot of computing power is needed to do all the calculations which have to be done on the car and can't be done in the cloud for safety reasons. So compute power is needed, and strictly speaking, there are very powerful processors available, and there are also concepts, or not only concepts, also obviously vehicles who are using multiple silicons to do the computing. But then the next challenge is, okay, the power consumption of these silicons is also quite high. And that means in the end, the range of a vehicle isn't really exciting. So obviously there are still some technical challenges to address, and silicons being part of them. But I think one other lesson learned is there has been a big hype about autonomous driving, and the market was really excited 5 years ago, 10 years ago, and still is. And in the end, now we have learned the hype is good to boost all the investments that have to be done, to boost the discussions the society has to do if they want that kind of technology, and also to kick off the legislations that also needed that the technology actually can be used. And I think that's something where we learned now, okay, there was a big hype, and some of the promises that have been made have been too optimistic for whatever reasons. And now in the learning curve and see, okay, technically it can be done. It still has a lot of challenges and also issues like power consumption or silicons and the heat the silicons will generate and so on. So technical issues. But due to the hype, we are now in the right discussion to address the technical challenges, the society challenges, and the legal challenges. And eventually it will happen with autonomous driving. But as Christoph said, the money is right now made with level 2 plus autonomous systems. And level 5 has the challenges Book mentioned, for example, and they will still take a long time to really address them, especially in a way that it is affordable and that it adds value to the current people movers we have with a human being behind the steering wheel.
Mm-hmm. Thanks a lot. So,
absolutely agree.
This is very important. Yeah, I think we are uncovering actually most of the main reasons why it's still not there. I would ask Christoph maybe to comment from one additional perspective. This is what I'm interested, because you are in the product team, so you're dealing with real products going out there. What is the level of, let's say, what is the ratio between the products that are realistic, let's say level 2 and like more traditional ones, and the ones that are in R&D that are far out there? So is it growing like in these promising technologies, or it's being decreasing? What is your view? Maybe you can give us a few, let's say, points on if we know that we are going to wait for a bit longer as we open it up, is it going to be even more long if there are no ongoing efforts in the actual products? So what are you working on in these kind of terms? Are you returning to traditional, if you get my point, or let's say?
Sure. Yeah. So I think also what Joerg said. So when you take a look on the Gartner hype cycle, the first time in 2012, we saw autonomous driving on the hype cycle. And you clearly see in 2013, 2014, the companies really invested highly into it and said, okay, started with investments. then I think the last 2 to 3 years, still a lot of companies invested, but also other companies decided to get out of the investment because they didn't see the return. And at the moment, we clearly see that we're at this slope of enlightenment, that people are really see, okay, how is the business running? And there the investment is going up again, and also the expectations. What I see is also from Elektrobit's perspective that we are more and more investing exactly in these products, which are maybe, let's say, not ready for manufacturing, or are in the cars in 2023, 2024, 2025. But we clearly see that also the investment in level 4 products is really needed. And there we are really also starting with investments to have products which are supporting, let's say, car manufacturers, but open speaking, more important, the truck industry. Because what I see is more the truck industry is the industry which will be the first that will bring, let's say, level 4 functions. That's what I personally believe. Because something that Joerg mentioned is the affordable, it must be affordable. And I mean, for level 1, level 2, you need maybe 1 camera, 1 long range radar, 2 short range radars maybe. But if you talk about level 4, we are talking about roughly 9 cameras, 6 radars, 8 short range radars. You need a surround view camera. Who can afford this really? If you think that you have, let's say, only for autonomous driving, maybe 100, or if the cost degrees 80,000 euros only for autonomous driving, and the allocation of a car and the utilization of a car will never provide a return on invest. So nobody can afford it. So that is why I also believe that level 4 and level 5 will first come in the truck industry. But even with this, we see that the entrance in the truck industry, that this investment is really needed to develop products which are, let's say, far out. And that's where we are really investing also.
Thanks. So that's pretty much what I was also experiencing from looking what's going on there. So being more realistic lately, but still keeping an eye on the trends and develop, maybe not with that intensity in terms of investment, but more realistic and more looking an eye on the real problems. Also, Christian mentioned one topic that we didn't further tackle. It's the lack of engineering workforce with understanding on the complexity, with appropriate education, I would say, in the end. So maybe this is the good point for Professor Tschürtz to tell us what he believes is the best education for people in autonomous driving developments. Is it traditional algorithmics, artificial intelligence, or maybe some system engineering? Or try to be objective, though.
Yeah. Milan, if you agree, I would like to mention also a few things to the artificial intelligence.
Yes.
Because Christian mentioned that safety is a crucial aspect. I fully agree to that. Yeah. If you are looking into the functional safety standards, for example, for ISO 26262, then there is a complete determinism demanded. This is not possible with artificial intelligence, let me say. Yeah. What we would need here is a rework of these safety standards on the one hand, and on the other hand, we have to find architectural solutions that we can, let me say, also show a safety case behind that. That's on the one hand. And to your question, what the education is best for that, what we could see, we need an education where people sees not only the software, not only the hardware, and not only the mechanics. What we would need is that we have engineers, they see the whole thing, the big picture behind that. I'm always mentioning a software developer who is developing software for a steering wheel. He cannot say, I don't understand how a steering wheel works. And this is something what we have in our master study program. Honestly speaking, this picture, this thinking on this big picture, because if we are looking at the safety topics, then we should not only look at the functional safety, we should see the whole picture. We should see the car, but we should also see technical components and how they act on the environment and all those kind of things. I think this is the challenge for the future.
Yeah, thank you very much. So this really, I think we covered it very, very good from this angle as well. And this leaves me basically with one last address for Professor Bogdanović. If I may be, let's say, direct to provoke, let's say, a scenario, because you, Professor, among this group of panelists and myself are the closest to the approving bodies, so to the legislators. So you are dealing with traffic regulation. So the regulatory bodies are your, let's say, contact points probably at this or that time. So you interact with them much more than we do mostly. So what do you think, when you particularly would be ready to let the autonomous car on the street of Novi Sad, let's say here in Serbia, or on the street of Vienna, that is, I don't know, level 4 autonomous or whatever, we can imagine the autonomous car and say, okay, from the standpoint of traffic, the regulation and the legislators, your best to the best of your knowledge. What do you think?
Yes, it is very, very important, and make a framework of legislative but I think that for development efficiency software, very important to explore real traffic flow conditions, and it is in my opinion the main problem for efficient autonomous vehicles in urban area, and for that is very important to make a risk assessment, and specification of risk is the first step by that, and I think that we expect, or actually that in the next steps of next level of autonomous vehicles, but I think that basic research and recognize some situation, specific situation, and help to make efficient autonomous vehicles, efficient software, efficient system, traffic system in all urban areas. And it is very demanding, and I don't know, maybe company who made autonomous vehicles have a plan for that.
So basically, the specification of risk and let's say the proof that somebody tackled the reality with and had the approach. Okay, I have a driverless vehicle. Let's say I can demonstrate the driving, but have I thought through the scenarios? Have I thought through the risks? Have I thought through all the operational situations with regard to all the participating entities? So whoever wants really to be taken seriously, I think he or she must bring those things on the table, and not only the demos of let's say the driven miles and whatever else, but to really say, okay, I modeled this, I invested time to model not only what I experienced, but also something that might happen eventually. So I think this is a pretty good also to circle this topic. And in the end, before I say thank you, because we are running out of time, I would like to let every one of you, like 1 or 2 sentences, but very, very shortly, and to be very direct. So autonomous cars level 4, which year? So the prediction of the year. I know it's impossible to do, but I will provoke you because we are recording this. So try to guess the year. It can be a guesstimate, like a well-informed or educated or almost uneducated guess. So maybe I can start first. So level 4 in the cities without the driver, 2045. Okay, Christian.
I'm a little bit more optimistic. I think here in China, they will go in 2030.
Okay. Joerg?
So first systems went going public in China this year, I believe. 5 cars driving around in a park. So there are many steps in between. So until a private person can buy a level 4 car, there I would also say we're talking about 2040 plus.
Okay.
But there are many steps in between, and some will be sooner available, significantly.
Soon it will be like nuclear fusion. It's always 30 years away.
No, but we have to differentiate. In the end, they have to be financial or economically feasible. And that will be the case for farming, for mining, for commercial vehicles, as Christoph mentioned, that are used on the highways or on fields, and they will be available sooner, and for a good reason, because there the cost benefit is there.
Okay, thank you. Professor Tschürtz?
Yeah, let me say it from the railway perspective, because here we have a timeline, more or less a vision, and it's much easier on the railway sector. Our target is 2030, and I hope this people mover concept will run on 2030, and I think on the urban sector it will be on 2035 approximately, perhaps.
Okay. Professor Bogdanović, do you have any predictions?
It is very, very demanding, but I believe, I am optimist always, and I believe that is possible.
Okay. During our lifetimes?
I don't know. It is not questions for me.
Okay. Christoph, you're the last man standing, so maybe the most optimistic in the nature of the work. So let's hear from you.
I think so. I think there will be robocabs, robotaxis 2026, 2028 with really with urban areas, like what Joerg mentioned. There are already some out in a dedicated park. And I think if we take a look 5 years back where we stood there and where we're standing now, I think to have it in, let's say, specific cities and areas in 5 years as robotaxis and robocabs 2026, 2027, to own it, and personally, I think we will not own such a car. We will just have a subscription, because in summer I maybe would like to drive a cabriolet, and in winter I would like to have my SUV to be safe. But I think such subscriptions for us will be available in 2035, 2040, something like that.
Yeah, maybe if not everywhere, then in well-designated areas, and I fully agree. So maybe we will experience that sooner, maybe not as a private ownership, but as some kind of taxi ride that is provided by some kind of company. Okay, our time is up. So thank you very much. It was a very, very interesting discussion. And I think I was afraid that it is going to diverge a lot because it's really challenging, but I think we managed to cover most of the topics. And again, I thank you all. And I also would like to invite you to stay with us and to follow through our interesting sessions and additional presentations, and maybe take part in some of the discussions throughout the conference. And I wish you all the luck and all the best in your everyday work. Thank you very much.